quiet voice settles in the dark and guides the mind outward. He moves through first light across gentle ripples in the ancient glow and into the slow gathering of galaxies. He traces the sun's soft breath, the harmony of planets, the hush of oceans beneath the ice, and the lace of rings and dust. With each calm fact, mystery relaxes rather than sharpens. He invites rest in a cosmos that keeps perfect time and lets wonder arrive like sleep. He moves through an origin that behaves like a long patient dawn, a slow easing of fierce brightness into room for distance and time to open, and in that softening the first rules quietly take their seats. In the earliest instant the fabric is dense and hot, a glowing ocean where particles appear and vanish with a steady churn, and yet the overall motion is not frantic but purposeful, drifting from chaos toward an uncomplicated order that can be measured and mapped. In that warmth, protons and neutrons meet and hold during a brief window. Astronomers call primordial nuclear synthesis, and from this small span come the first atoms, mostly hydrogen, with a smaller share of helium and only faint traces of lithium. A simple recipe written once and then left to rest. The universe continues to expand, and as it does, the average energy drops, the fog of radiation thins, and the pathways of light begin to lengthen toward clarity. At first, light cannot travel far because free electrons scatter each photon again and again, turning the whole young cosmos into a bright but opaque veil, and this veil is uniform enough that no point stands out as special. Time passes, the pressure eases, and a gentle change arrives when electrons settle into orbits around nuclei. Astronomers call this recombination, though it is a first joining rather than a reunion, and this joining clears the fog so that light can move freely for the first time. That liberated glow spreads everywhere and endures as a faint background, a nearly even wash of ancient radiation that observatories in space and on high mountain deserts record with calm patience, finding tiny ripples in its temperature that whisper of seed patterns laid down before any star was born. Those ripples are small, but they matter, for gravity leans into them and begins to gather gas along their shallow slopes, and the gathering is unhurried, a long drift that allows the earlier structures to outline themselves without haste. Composition remains simple in this clearing age, with hydrogen providing a quiet baseline and helium adding a second note, and there is no carbon yet no oxygen, no dust, only clean gas responding to gravity and to expansion in a straightforward dance. Expansion continues everywhere at once, increasing the distance between any two markers without needing an edge to push against, and homogeneity and isotropy, words that mean sameness in place and in direction, on large scales make the view symmetrical enough to soothe the imagination. In such a setting, the first stars arrive not as an abrupt event, but as a threshold passed when cooling gas clouds can collapse deeply enough that the pressure at their cores sparks fusion, the joining of light atoms into heavier ones, with a release of energy that shines. These earlier stars likely grow large, burn hot, and live brief lives. Their light a hard blue that flares and then settles into memory, yet their brief presence is generous, because within their cores, the first heavy elements form and later return to space through winds and soft explosions that enrich the plain gas with new ingredients. The background glow that escaped at recombination continues to cool and stretch as the universe grows, and today it rests only a few degrees above absolute zero, a phrase that means the point where motion nearly stops, and this afterglow is mapped finely enough that its subtle mottling can be compared with models of early growth. Instruments funded and flown by the National Aeronautics and Space Administration and the European Space Agency trace that pattern with disciplined care, stacking long observations to reveal gentle contrasts that confirm the story of a universe that began smooth, collected its small imprints, and let gravity do the quiet work of turning them into a scaffold for everything that followed. The picture that emerges from these measurements is not an explosion into empty space, but the beginning of space itself, a swelling of the stage rather than a blast of objects across a room, and this change in viewpoint calms the mind, because it replaces the noise of imagined debris with the steady widening of the arena. He lingers on a modest analogy that helps the scene stay gentle. Raisins in a rising loaf do not fly on their own. They drift apart because the dough between them expands, and any raisin can believe itself at the center without being wrong, since the pattern looks the same from every location. That sameness matters because it tells him that the early rules are universal, and that no observer holds a privileged vantage, and it folds the whole cosmos into a shared cadence, a single quiet rhythm that hums beneath the later complexity of stars and planets and life. Within that rhythm, small differences still count for. They guide where gas will gather and where darkness will remain, and the next chapters of structure are contained in those first quiet numbers. The slight excess here, the slight deficit there, all within a field that is otherwise impressively even. He notes that uncertainty does not break the calm. When the limits of knowledge appear, they appear as soft edges where the light of evidence thins but does not vanish, and the method is clear: state what is known, mark what is inferred, and let patient instruments extend the map without hurry. He observes that the curve of events holds to a soothing sequence: hot origin, simple chemistry, clearing of light, gentle growth of seed patterns, first stars enrichment and then broader structure, a line that gives the mind a place to rest between each step. In the spaces between steps, light travels and cools, matter drifts and gathers, and the ratio of hydrogen to helium stays almost exactly as it was set, anchoring calculations that are checked in laboratories and in stellar spectra, with a precision that does not disturb the quiet. He considers how even the large words of this subject carry calm when placed with care, because they do not demand urgency. They simply describe the way things proceed when there is ample time. If there are earlier moments that instruments cannot yet reach, he allows them to remain off stage for now, present as a possibility, but not needed to hold the mood, because the story already provides a serene arc that curves from brightness to clarity without sharp corners. The background afterglow, the first atoms, the first stars, and the rule of expansion together establish a foundation as steady as a metronome set to a very slow beat, and on that beat the rest of the tale can move inward without strain. He pauses at this threshold, feeling how the origin in quiet light sets a tone that never quite fades, a low note that continues beneath every galaxy and every planet, and every life that will later look up, and he carries that note forward as the scene turns toward the wide gathering of stars that forms the next layer of the calm night. He attends to the background whisper that fills all directions at once, a faint and even afterglow that left its source when the universe first allowed light to travel without constant scattering, and he treats this glow not as noise but as a calm archive of beginnings. The afterglow rests a little under 3 degrees above absolute zero, a diffuse warmth stretched thin by expansion across vast time, and it greets careful instruments with the same patient tone no matter where they look. He pictures those instruments as steady listeners, the Wilkinson microwave anisotropy probe placing a gentle ear to the sky from its quiet orbit, and later the Planck mission of the European Space Agency, refining the map with finer focus, both supported by long years of calibration and cross-checks that trade haste for certainty. They record a nearly uniform field that does not shout but hums, and within that hum live tiny temperature differences, small patches slightly warmer and slightly cooler than their neighbours measured in parts of 100,000 modest imbalances that act like a soft fingerprint left by the first ripples of structure. He lingers on how those ripples arise from sound waves in the early plasma, thick and glowing mixture of light and matter, in which pressure and gravity set up slow oscillations, crest and trough following one another with the unhurried rhythm of a drum heard from very far away. When recombination arrives and electrons settle into their orbits, the plasma clears and the sound stops freezing those waves into a pattern that the afterglow carries forward without distortion, except for the gentle stretching of expansion. The instruments see that pattern not as lines, but as a distribution of sizes and strengths, and scientists describe it with a power spectrum, which is only a way to list how much structure appears at different angular scales. He translates that idea back into a more soothing picture of mottling, like the surface of milk warmed slowly in a pan. The first broad crest in that spectrum reveals the typical scale of the sound at the moment it stopped, while the next crests and dips echo harmonics of the same ancient drum, and together they place calm constraints on the amount of ordinary matter, the balance of invisible matter that does not shine, and the energy that drives the expansion to continue its steady widening. He notes with ease that the afterglow also shows a faint polarization, a preferred direction in the way its light waves are oriented, created by scattering near the time of last contact between light and matter, and this polarization draws soft lines across the sky that carry additional information about the timing of the first stars and the depth of that clearing fog. He lets the facts fall into a gentle sequence, a nearly smooth field, faint ripples with a characteristic scale, a polarization pattern that agrees with the temperature map, and a set of measured numbers that repeat across independent instruments and across seasons in space. From this sequence, a picture emerges that does not require drama, only patience, because the afterglow behaves like a clock and a ruler together, telling both how much time has passed since the first light set out and how large the universe appears on the grandest scales. This clock suggests an age measured in many billions of years, long enough to turn violent origins into quiet order. The ruler suggests a geometry close to flat on distances larger than any cluster of galaxies, meaning that parallel lines would stay parallel across the visible stage. He reflects that the words sound large, but the feeling they carry is not heavy. It is restful to know that the distant view holds steady, that no direction is special, and that the same gentle hum pervades the whole. He thinks about how the afterglow also bears the imprint of slight motion, a dipole pattern, where one side of the sky is gently warmer and the other gently cooler, because the Earth and Sun and their local neighbourhood move through the field, and he appreciates how this motion can be removed to reveal the deeper uniformity beneath. Once that motion is accounted for, the remaining ripples tell a more ancient story, unaffected by local drift, a story of seeds that gravity will later amplify into the scaffolds of galaxies. He acknowledges that the afterglow does not tell everything. It speaks mainly of the era before the first stars lit up, and it whispers of earlier processes we do not yet see directly, such as a very early period of rapid stretching that smoothed and flattened the stage. He keeps speculation light and measured, imagining that very early stretching as a calm breeze that evened out wrinkles, while leaving faint quantum grain as the origin of later ripples, then returns to the measured facts that support a simple narrative of expansion, cooling, and pattern formation. He appreciates the care with which ground-based telescopes join the effort, choosing high and dry sites where the air is thin and still building arrays of receivers that stare at the same patches of sky for months and years until the noise averages down into silence and the signal remains. He imagines the data arriving not as sudden revelations but as layers of long exposures stacked, checked, and compared, each layer placed with the same unhurried attention someone might give to placing smooth stones in a garden one by one until a path emerges. The afterglow once mapped becomes a backdrop for everything else. It sets the initial conditions for the growth of structure. It calibrates distance measures used for the positions of galaxies, and it anchors the ratio of ordinary matter to invisible matter to the energy that acts like a pressure in empty space. It is soothing to notice how many independent measures point to the same gentle balance, and how the maps drawn by separate teams align until their borders become seamless. He considers the way the afterglow reaches us from every direction, with the same tone, and how that sameness allows a rare kind of confidence in a field filled with vast numbers, and confidence itself quiets the mind because it reduces the urge to force meaning where none is needed. He lets his attention drift to the future of the afterglow, which continues to cool as expansion precedes its characteristic light stretching into longer and longer wavelengths, until in ages beyond any present concern it will be too faint for any practical receiver to collect a slow fade that mirrors the slow reveal. That thought does not trouble him. It is simply another cycle, viewed on a scale too large to disturb the present, another tide moving in a basin larger than imagination. He returns to the present comfort that this radiation provides. It is a universal frame of reference for careful thought, without breaking the deeper rule that no place is special, and it is a time capsule that needs no maintenance and cannot forget. He senses how this calm archive supports the next steps of the story, because it gives gravity a pattern to follow and gives chemistry a context in which to begin. And he understands that by listening to the background whisper, he has already learned where the gentle valleys and ridges lie, the places where gas will gather, and where it will thin the outlines of all later quiet structures. He rests with that knowledge and allows the narrative to drift forward from the afterglow's evenly mottled cloth to the slow gathering of galaxies that will stitch themselves along its faint threads, moving from whisper to shape in a sequence so gradual that the change feels like the natural breathing of the cosmos. He watches structure gather with the patience of a tide that knows the shore will come to meet it. A slow drawing together guided by gravity along lines first hinted at by the ancient afterglow, and the pace is so measured that each step seems to wait for the next with deliberate calm. The matter that shines is only a trace of small lamps on a scaffold of darker mass that does not give off light, yet shapes the path that everything else will take, and in this unseen lattice, gas slides inward toward gently steepening basins. Over stretches measured in many billions of years, tiny clumps merge into larger halos, and the mergers are not blows, but embraces orbital dances that trade energy for a deeper equilibrium until a new center emerges that holds the sum in a steadier form. The gas that arrives does not fall straight to the middle. It carries a little spin from the uneven past, and that spin stores itself as rotation, spreading the material into a disk where friction and cooling allow clouds to settle and then fracture into knots that grow quiet stars. He observes how the first large galaxies do not appear all at once but unfurl from seeds, some becoming smooth ellipticals with rounded light, and some becoming spirals with thin disks and extended arms, and the difference reflects histories of gentle collisions and continued gas supply rather than a simple rule. Rotation curves keep their shapes in a way that soothes the mind with repetition. Far from the center, the stars still move with speeds that do not fade as simple gravity from visible mass would predict, and this steady speed points back to the halo of darker matter that holds the light with a broader hand. The images that make this visible arrive from a procession of steady instruments that look and look again, the Hubble Space Telescope drawing long exposures that reveal faint outer regions like breaths around bright cores, the Very Large Telescope of the European Southern Observatory, gathering spectra that turn motion into numbers, and the James Webb Space Telescope peering farther back in time to find small and red patches that mark youthful systems still in the quiet rush of assembly. Their views line up with maps of the larger environment where galaxies do not sit alone but string themselves along filaments that cross vast distances and meet at soft nodes, a three-dimensional web whose strands are traced by clusters and whose empty gaps cradle peaceful darkness. He considers how the language of clusters and filaments can sound busy, but the motions are slow and regular, held in a balance between inward pull and outward expansion that rarely hurries anything, so that a single group may take many billions of years simply to reach a relaxed state after a minor encounter. Within massive clusters, the gas between galaxies is heated to a diffuse glow, and that glow reveals itself in gentle X-rays that fill the basin like a warm mist, while the combined mass bends light from farther galaxies into stretched arcs and soft rings, a natural lens that confirms the presence of the deeper halo without the need to see it directly. He lets the pattern become ordinary in his mind. Small systems gather first, then merge, then settle, and the trend continues across scale after scale, so that dwarf companions drift along the outskirts of larger spirals, and tidal streams mark their quiet passage with thin ribbons of stars that wrap like silk around a steady hub. Star formation rises where cold clouds can collect and then slows as gas is used or warmed or carried away by gentle winds from clusters of young stars, and the soft maintenance of central black holes that feed lightly and exhale energy into their surroundings, keeping the balance without great noise. Even these central objects which sound fierce behave within a cycle that is more regulator than storm brightening, when fuel arrives, and dimming when the pantry is bare, a thermostat effect that allows a galaxy to keep its light output within a modest range over long times. The shapes we learn to name are not rigid but living in slow motion. Spiral arms are not fixed structures, but patterns that move across the disk like waves, gathering gas into beads of starbirth, and then letting those beads drift on while bars carry angular momentum outward and bring material inward to feed the core. He finds comfort in the regularity of scaling relations that connect the light and the motion, and the total mass links repeated across countless systems, so that a galaxy's rotation or velocity spread tells with gentle accuracy how heavy the whole must be, and these relations turn the wide sky into a set of well-tuned instruments. Surveys that sweep large areas, such as the careful maps made by the Sloan Digital Sky Survey, show that the mix of shapes and sizes depends on environment in ways that are understandable in slow detail. Denser regions foster rounded forms that have lived through many small gatherings, while quieter outskirts sustain thin disks that have had time to regrow arms from new gas. He imagines watching a single system across its full arc first as a small companion that spins quietly in a filament, then as a participant in a soft merger that thickens its disk, then as a settled spiral with star-forming rings traced by pink knots of ionized gas, and finally perhaps as a rounded elliptical. After several later meetings, its stars moving in all directions like grains in a stirred basin, its gas warmed and content to glow faintly rather than to condense. The distant past is present to modern instruments, because looking far means looking back, and so the youngest galaxies he can see appear small, clumpy and bright in irregular patches, as if growth were still choosing directions, and across successive slices of distance, those patches smooth into more recognizable forms, with clean arms and defined bulges and evolution as gentle as frost melting into still water. Even the growth of chemical elements follows a quiet trend, with early stars forging the first dust and metals, and later generations inheriting that richness, so that the outer parts of large spirals often carry simpler compositions, and the inner parts hold layers of more complex ash from long cycles of formation and return. In the thick halos around bright disks, swarms of ancient star clusters persist, as patient witnesses, each a dense and old family that formed early and then kept its shape, and their motions trace the mass beyond the light, while their colours hint at the timing of the galaxy's early meals. He reflects on how the laws that steer this growth are few and steady, and how their simplicity gives rise to the variety with no need for chaos, since initial conditions, gentle feedback and environment together shape the final forms without special pleading. The wider web that holds all this together resembles a frozen memory of the first ripples in the afterglow translated through gravity into walls and threads and voids, and this translation is slow enough that nothing feels sudden, just a continued fulfillment of a plan drawn in soft pencil at the beginning. He considers the open questions with the same calm tone he holds for the knowns, how exactly the first tiny seeds gained their early mass, how the darker scaffold interacts beyond its pull, whether small departures from the simplest model might reveal themselves in the faint distribution of the thinnest satellites, and whether the murmur of weak lensing measured by large future maps will sharpen the picture into even finer relief. None of these questions press as alarms. Each is an invitation to watch longer, and to gather more light, and to let the slow arithmetic of the sky bring the answers into view as the seasons of instruments pass. He ends this moment of the story by resting in the image of a spiral seen face on a flattened luminous whirl, with a soft bar across its centre, and two grand arms that feather into many strands at the rim, dust lanes combed into curves, star-forming knots set like small beads along the paths, and a thick halo of older stars around the edge like a pale wreath. It turns so slowly that a single rotation will take hundreds of millions of years, and in that scale the human sense of hurry dissolves into the larger, quieter clock that galaxies keep together, as they move along the filaments toward their next unhurried meetings. He follows the quiet rivers of unseen mass that thread the cosmos, a scaffold invisible to eyes yet steady in its guidance, and he lets the evidence arrange itself like a gentle current rather than a surge. Stars near the edges of spiral galaxies circle their centres with speeds that remain almost unchanged across great distance, a calm defiance of what the light from gas and stars alone would predict, and those nearly flat rotation curves speak of halos made of something that does not shine yet extends well beyond what telescopes can see. In clusters of galaxies the same hidden hand appears because the orbits of many galaxies within a single cluster, and the soft glow of hot gas between them, both require more gravity than visible matter supplies, so the total mass must include a wide reservoir that is clear to gravity but dark to light. The unseen mass also reveals itself in the way it bends light from farther objects, stretching background galaxies into faint arcs and rings, a natural lens that turns clusters into slow instruments, and this bending can be mapped into a distribution of mass that includes a broad, smooth halo outshining the stars in influence, even while remaining hidden. He remembers that a famous collision of two clusters shows light hot gas and gravitational mass drifting slightly apart, as if the unseen component passed through with little friction, while the hot gas felt drag, and this separation quietly strengthens the case that the dominant mass is not ordinary gas kept out of view, but a different and more elusive population, On larger scales, the same presence is needed to explain the pattern of structure that grows from faint ripples in the ancient afterglow into filaments and nodes, because gravity gathers ordinary matter too slowly on its own to build the observed web within the available time. The unseen mass makes deeper wells that help the visible material find its places. He thinks about the character this unseen mass must have to fit so many gentle constraints at once. It must cling to gravity and almost nothing else. It must move more like a rain of slow particles than like a fast wind of light ones. It must avoid colliding with itself in any strong way, and it must be present in a stable share across the ages so that the cosmic clock set by the background afterglow and the count of galaxies remain in tune. When careful teams simulate the growth of structure by letting a large number of tiny masses move under gravity alone, they recover a web of filaments and halos that resembles the observed sky in restful detail, and each galaxy sits within a larger halo whose density rises toward the center in a smooth way that looks nearly the same from one halo to another over a wide range of sizes. He notes that the inner steepness of such halos predicted by these simple simulations faces a mild puzzle when compared with the slow motions of stars and gas near the centers of some small galaxies, where the density seems to flatten into a soft core rather than an ever steeper slope, and he takes comfort in the patient work that tries to reconcile both views by adding the feedback of star formation and gentle winds to the models which can soften the inner profile without removing the larger harmony. The most delicate laboratories for the unseen mass are tiny satellite galaxies that circle larger hosts in quiet, elongated orbits. Their light is sparse, but their mass inferred from star motions is large, so that each appears as a heavy halo wrapped in a faint veil of stars, and the balance of their motions places firm limits on how warm or soft the unseen particles could be, because too much warmth would erase such small structures. He thinks of star streams, the thin ribbons shed by dissolving clusters as test lines stretched through a galactic halo. Where they kink or fan, the unseen mass leaves gentle fingerprints and future maps that chart. Many streams may reveal whether the halo is perfectly smooth or peppered with small clumps. He considers alternate candidates with a calm and methodical tone. Primordial black holes would be dark and massive and follow gravity, but a wide range of masses has been ruled down by the absence of the expected brief brightenings of background stars, and by the way the afterglow would have been disturbed, so only small windows remain, and they do not seem large enough to hold the full share. Light relic particles that move near the speed of light would smear small structure and erase the tiniest galaxies. The universe contains many small galaxies, so such fast particles cannot make up the majority. Particles that interact with themselves too strongly would round out cluster shapes and produce drag in collisions. The observed shapes and separations allow only gentle self-contact, and so the unseen mass must be close to collisionless. He lets these constraints sit in a circle like stones around a calm pool, and in the middle he places the simplest picture that remains a cold, nearly collisionless population that answers gravity and otherwise stays quiet. He visits the human search with the same soft cadence. Underground rooms lined with rock and salt and still air hold vessels of noble liquids that wait for a subtle tap, the tiny push a passing particle of unseen mass might give to an atomic nucleus, and years pass as teams listen for a handful of clear strikes among a rain of lesser noises. Skyward instruments look for the faint light that might mark the meeting of two unseen particles in dense regions like the inner parts of halos, while particle colliders watch for missing energy that could signal the birth of something that slips out without light. To date, these searches have set limits that steer expectations but have not declared discovery, and he takes repose in the honesty of that outcome because it means the map is built with care and patience, and not with haste. He reflects on how the unseen mass gently anchors more than spiral speeds and cluster shapes. It sets the pace at which gas cools and falls to form stars. It regulates the sizes of disks. It provides a calm buffer that keeps small encounters from tearing galaxies apart. And it gives the cosmic web its quiet spine. He observes how the unseen mass does not clump into thin disks as stars do, but remains in a rounded halo, and so it barely participates in bars and arms, yet it steadies their dance by adding weight that resists sudden change. He imagines a spiral galaxy seen edge-on with a thin strip of dust and starlight, crossing a wide, faint oval of influence that cannot be seen but can be felt in every orbit, and that oval reaches far past the last bright knots, holding the outermost traces in an embrace that never tightens or loosens too quickly. He lets the open questions rest in a gentle list within his mind, not written, but felt what field or symmetry gives the unseen mass its silence. Whether a small self-interaction allowed by clusters might leave a soft imprint in the shapes of dwarfs. Whether a handful of very light particles contribute a minor note to the chorus, and whether a rare kind of compact dark object shares the halo with the more common and diffuse sea. He keeps speculation calm and provisional, suggesting that the unseen mass may have been created in the early thermal bath, and then cooled out of contact, or that it formed through a quiet misalignment of a light field that later settled into a wave which would make halos with delicate interference patterns that future measurements of star streams might detect. He closes this stretch of the river by returning to the feeling rather than the mechanism. The unseen mass does not blare. It underlies it, steadies it, gathers and holds, and because of it, the cosmos gains a slow memory of its first ripples. He carries that memory forward as the story turns from the broad scaffold to the long pulse of starlight that runs through it, a heartbeat that translates gravity's quiet valleys into the measured birth and fading of stars across many billions of years. He feels starlight as a long pulse that rises and settles across ages, a gentle heartbeat, traced over the scaffold of halos and filaments where gas cools, condenses and kindles into steady fires that change the chemistry of the universe while keeping an unhurried pace. In quiet clouds, dust and molecules shade the interior from harsh light. Temperature slips downward and pressure relents until gravity draws the cloud into denser pockets that rotate and flatten, turning collapse into a disk around an infant star. In that disk, small grains meet and stick while the center grows warm and then hot, and when pressures at the core become high enough for hydrogen to fuse into helium, a new star steps onto the main band of the Hertzsprung-Russell diagram, the map that relates brightness and temperature and lets one read a life in simple coordinates. The time a star spends on that band depends on its mass, and the range is broad enough to calm the mind with its spread-heavy stars, burn with fierce brightness, and live short lives measured in only a few tens of millions of years, while gentle red stars sip their fuel and may shine for a time longer than the current age of the universe. Most stars settle into the middle, a steady company that holds a balance between inward pull and outward light, and this balance, called hydrostatic equilibrium, is not a fragile truce but a quiet law fulfilled at every depth. He watches the population as a chorus rather than a collection of soloists. At any time, a galaxy contains stars at every stage, and the combined glow follows smooth rules that observers learn to read with instruments that separate light by colour and compare it with models of how populations age. The National Aeronautics and Space Administration and the European Space Agency, along with many ground observatories, build catalogues of nearby stars precise enough to test these models, and their agreement with observation lends a soft confidence to the idea that starlight rises in waves as gas supply allows and then declines when feedback and heating ask the clouds to pause. He turns over the idea that star birth follows a statistical pattern, favouring low-mass stars over high-mass stars, and that this pattern remains remarkably similar from region to region, so that across time galaxies weave similar cloth with threads of many thicknesses but a familiar mix. Massive stars set the beat for changes, even though they are few, because their light and their winds move gas and their endings spread heavy elements into space. Between birth and ending, each star is a small laboratory where nuclei rearrange with slow precision. In the core, hydrogen becomes helium through a chain of steps that release energy as light, and when hydrogen dwindles at the center, the core contracts and heats until helium can fuse into carbon and oxygen. In stars with more mass, further steps build elements up to iron, the point at which fusion no longer pays an energy profit. In smaller stars, the process stops earlier, but even there whines and gentle pulsations bring carbon and oxygen to the surface, and dusty shells form and drift away like slow breath, carrying elements that future clouds will inherit. He rests on the image of a red giant, its envelope expanded and cool, its surface turning a shade of orange that recalls dusk, and within that calm appearance layers move, mix and release molecules and grains into the surroundings. He follows the endings with the same tranquil cadence. Some stars leave behind white dwarfs, dense and warm cinders that cool for eons, simple in composition and predictable in their glow, useful as clocks that age in a steady way. Others more massive end in supernovae, a word that sounds sudden, but that he treats as the final step of a long preparation. The core collapses when its pressure fails to resist gravity. A shock forms, and in a brief span the outer layers are cast off, enriching the neighbourhood with elements from oxygen to iron and beyond through rapid captures of neutrons in the hot flood. The shock can be intense, yet the effect on the larger galaxy is a quiet reset that encourages new clouds to form at the edges of expanding shells, so even the dramatic carries an aftertaste of balance. In the densest remnants, neutron stars and black holes persist as small anchors that sometimes join companions, and when they do, they stir space itself into waves that ripple outward, a new kind of light that observatories have learned to hear. He appreciates that variable stars add their own steady rhythms to this quiet symphony. Cepheid variables swell and contract with a regular period tied to their true brightness, and this relation allows distance to be measured by comparing how bright they appear with how bright they must be. Long-term programs with space telescopes and ground arrays track these gentle pulses across nearby galaxies, connecting one rung of distance measures to another so that the scale of the universe can be checked and refined without rush. Other variables, such as eclipsing binaries where one star passes in front of another, add different clocks whose patterns are as regular as tides, and these too feed the larger habit of turning repeated cycles into knowledge. He sits with the population view again, thinking of how a galaxy's light at any moment reflects the sum of many lives. A soft blue from young clusters, a golden wash from older stars, a faint ultraviolet from regions where the most massive are still present, and a long infrared glow from dust warmed by starlight and by the quiet hearths of small red stars that fill the disk. Instruments separate this blended light and match it with predicted spectra for populations of different ages, and from this match one can infer how the star formation rate rises and falls over time. Many galaxies show a history that starts softly, grows to a broad crest over several billions of years, and then slowly declines a bell-shaped curve that feels like a natural breath rather than a command. He notices that cycles also occur on smaller scales within a single galaxy, where a spiral arm moving like a pattern wave gathers gas into denser clouds that then form stars, so that along the arm glittering knots appear with slight offsets, the youngest near the dust lane where compression is strongest, and older clusters trailing behind as the pattern passes. Even here the pace is measured, and the offsets turn a static picture into a clear sequence that can be read like a score. He considers that the chemistry of the interstellar medium responds to this pulse in an orderly way. With each generation of stars, gas gains a little more carbon, a little more oxygen, a little more nitrogen, and heavier elements, and these additions allow cooling to proceed more efficiently, fostering new molecule formation and dust growth, which in turn encourage cloud collapse. This feedback is not a loop that runs away, but a tempered one, because radiation and winds and supernovae also warm and disperse, gas-enforcing periods of rest between bursts of activity. Over long times, the mix reaches a gentle balance set by how much fresh gas arrives from the halo and from the thin drizzle along filaments, and by how much leaves in slow outflows maintained by clustered star formation and the mild work of central black holes. The sense of a heartbeat returns as he thinks about cosmic time at large. The universe began with no stars, moved into an era when the first ones formed and reionized the gas, with their light climbed to a peak when galaxies formed stars at a rate many times higher than today, and has since relaxed into a quieter tempo where growth continues, but with fewer bright flashes. The pulse remains, but the volume has lowered, the same song carried forward at a comfortable level. He lets the open edges rest in view without strain. Uncertainties remain about the exact pattern of early star formation, about the way small galaxies managed their gas in the presence of the first heating, about how often very massive stars formed in the young universe, and about the precise role of magnetic fields and rotation in shaping disks around newborn stars. He treats these as gentle questions the cosmos will answer, as instruments collect longer exposures, and as models refine their handling of processes that range from nuclear steps to cloud turbulence. He closes this segment with the image of a dark molecular cloud lit from behind its edge, traced by a thin rim where starlight sculpts gas into calm waves, while inside a cluster of forming stars glows in the infrared, hidden to ordinary eyes but clear to patient observatories. The stars within will step onto the main bandage along their steady tracks, and then leave their memories in dust and elements for the next cycle, and the galaxy will keep its gentle heartbeat neither hurried nor delayed, a long pulse that carries everything forward with an ease that invites rest. He turns to the maps themselves, the calm portraits made by patient observatories that watch without hurry, and collect a light until it settles into meaning, and he lets the craft behind these images feel like work in a quiet studio rather than a race. The National Aeronautics and Space Administration and the European Space Agency place instruments above the weather into steady darkness, where the sky does not blink, and there the Hubble Space Telescope and the James Webb Space Telescope hold their gaze for long stretches, gathering faint photons until shapes appear that were hidden before. On Earth, domes open on clear nights, and mirrors breathe the cold air, and observatories from high deserts and volcanic summits join the same effort, each contributing a careful piece to a wider picture that no single instrument can complete alone. He notices how the method favors time and repetition. A single exposure is only a beginning. Many are aligned and combined so that random noise falls away while true features remain, and the result is a surface that looks quiet because it is supported by patient accumulation. the process does not rush past its own checks. Every raw frame carries the marks of its path through glass and electronics, and before those marks can be removed, they must be measured. Flat fields correct small changes in sensitivity across the detector. Dark frames subtract the faint current of the instrument itself, and cosmic ray strikes are identified and set aside so that they do not masquerade as stars. Each map begins as a mosaic of small pieces. A telescope frames a patch of sky, records it with detectors that count single quanta of light, and then steps to an adjacent patch repeating the motion until a grid surrounds the chosen field. Later, the pieces are matched at their borders with care, the background levels are balanced. The stars serve as anchors so that positions and brightness agree from tile to tile, and the seam disappears into a continuous view, where the subject is too faint for any single long stare. Many shorter stares are stacked over months and years, a slow layering that turns near invisibility into a soft, reliable signal. The light itself arrives in many bands from long radio waves that slip past dust to short ultraviolet, that traces hot young stars, and each band adds a layer to the portrait. The Atacama Large Millimeter Array draws the cool structures of gas and dust, where stars are born, showing filaments and rings that ordinary eyes cannot see, while optical instruments trace the glow of mature stars and the gentle absorption of dust lanes, and infrared cameras follow the warmth of grains, and the light of distant galaxies shifted to longer colors by expansion. X-ray telescopes and ultraviolet spectrographs provide their high-energy notes, revealing hot gas pooled in clusters, and winds from newborn stars and radio arrays trace magnetic fields and the smooth sheets of diffuse hydrogen. The map becomes truer as these layers are brought into alignment because each one corrects the others and turns possible misreadings into solid understanding. He attends to the quiet rituals that keep maps true. Detectors have their own small quirks, some pixels a little more eager than others, some a little less, and these responses are charted and corrected. The atmosphere makes its own marks on ground-based work, introducing blurs and twinkles that are measured with guide stars and corrected with adaptive optics, tiny mirrors that flex many times each second to cancel the shimmer, leaving a stable point where there would have been a smear. Star positions are tied to catalogue so that a change of instrument does not shift the sky, and photometric standards make sure that a brightness measured today means the same as one measured long ago. Once the light is captured, it can be separated by colour into spectra, long ribbons, where the brightness at each wavelength is recorded. In those ribbons, lines appear where atoms and molecules have absorbed or emitted light, and their positions and shapes tell of temperature, density, motion, and composition. He imagines a calm laboratory in which each feature is compared with a standard crafted from careful physics, and the match becomes a set of numbers that describe reality without hurry. With spectra, a galaxy's redshift becomes a distance, a star's wobble becomes the pull of an unseen planet, and a cloud's cooling lines become a record of molecules that will one day shade a nursery for new suns. Survey work extends this approach across wide areas. Projects plan to revisit where the weather permits season after season, returning to the same fields to catch changes and to deepen the view. The result is a living atlas where transient light is logged beside permanent features, where a supernova leaves a soft signature in one season, and a newborn star adds a faint brightening in another, and where slow-moving objects trace arcs that can be followed and predicted. Satellites that scan the entire sky, such as the mission that maps the positions and motions of more than 1 billion stars, turn parallax into distance and proper motion into orbits, and those orbits reveal streams that were once clusters and companions, thin rivers of stars that outline the gravitational shape of the halo. The Transiting Exoplanet Survey satellite watches many bright stars for tiny dips, and ground networks confirm the dips and weigh the worlds. Together they build a catalogue that grows by steady addition rather than by rare leaps. Radio arrays add another layer of serene detail. By combining signals from many dishes spread across many kilometres, they create a virtual mirror far larger than any single structure, and they do so by aligning wavefronts with exact timing. With this method, jets from the hearts of galaxies can be traced across light years, their knots moving outward with steady strides. Neutral hydrogen gas can be mapped across spirals to reveal how disks breathe and turn, and faint radio pulses from spinning neutron stars can be timed so precisely that even slight drifts in their arrival reveal the passing of gravitational waves. He notices how the discipline of mapping encourages gentleness in interpretation. When a feature is seen at one wavelength, it is checked against others. When a pattern appears, it is tested against simulations that grow structure under known laws and against models that calculate how light would pass through gas and dust arranged in plausible ways. In this back and forth, surprises become opportunities to refine the portrait rather than reasons for alarm. The discovery of a faint ring becomes a clue to shepherd moons. A soft arc of starlight becomes evidence of a past encounter. A dim glow around a galaxy becomes a halo of stars lifted from small companions over long times. He reflects on how the public images that emerge from this work are both truthful and artfully prepared. Colours are chosen to represent wavelengths beyond human vision in a way that preserves contrast and relationship, and the scaling brings forward both bright cores and tender outskirts so that the whole can be seen at once. Captions explain that these choices are mappings rather than decoration, and the result teaches without hurry, inviting the eye to rest. In classrooms and quiet planetariums, the same scenes unroll slowly, and people who may never operate a telescope can still feel the calm order in the way the universe arranges itself. He keeps the role of small instruments in view as well. Modest telescopes in many countries join coordinated networks to measure the brightness of variable stars, the dips of planets crossing distant suns, and the paths of near-Earth objects, each observer contributing a thread that when woven with others becomes strong. The shared cadence of repeated measurement builds confidence and reveals long-term trends that no single night could capture. Professional and community efforts align, and the science becomes sturdier for being distributed. Finally, he considers the maps yet to come, and he does so without urgency. New surveys will sweep the sky with faster cadence and deeper reach. Radio arrays will extend to even larger baselines, and future space telescopes will continue their long stares into fields chosen for their calm. The questions they will address are detailed rather than dire: how faint structures extend around galaxies, how often small planets form in the gentle zones where liquid water can persist, how the cosmic web guides gas into disks, and how the slow wind from stars enriches the next generation. He does not rush to answers. He trusts the same method that has made the present map so soothing to behold: careful design, repeated observation, open comparison, and the quiet patience to let signal emerge. What these maps offer beyond their science is a pace, a way of seeing that moves no faster than the light allows, and in that pace he finds the deep ease that carries the story inward to the edge of the sun's domain. He drifts inward toward the sun's distant frontier, where the quiet outskirts of the solar system hold icy bodies that move along elongated paths like beads, circling on a very long thread, and he lets the scene arrange itself as a set of nested calm boundaries rather than sharp walls. Far out, a cloud of potential comets surrounds the system in a vast sphere, an archive of small worlds that formed close to the giant planets and were lifted into distant storage by slow encounters, and this cloud reaches so far that even light, which crosses space at the fastest pace allowed, would need many months to travel from its inner shore to its outer fringe. Closer in still, well beyond the known planets, a wide belt of icy objects lies in a flat ring that keeps the general plane of the solar system, and within this ring, the bodies turn with gentle regularity under the combined pull of the sun and the rhythm of the outer planets. He pictures the belt as a quiet street with many walkers, some round enough to count as dwarf planets, and many more as small irregular fragments, all made of rock and frozen volatiles, mixed in proportions that preserve the early chemistry of the sun's nursery. Resonances with Neptune draw subtle patterns into the population, placing some objects in orbits that return to the same geometric relationship again and again, so that the pattern keeps order without the need for close encounters. The objects that wander too near to the giant planets can be nudged onto more stretched paths that carry them inward toward the planetary realm or outward toward the deep cloud, and it is this gentle traffic that seeds the comets which later sweep by the inner worlds with long thin tails. He considers the sun's influence as a breath that reaches far into space. From the surface of the star, a wind of charged particles flows outward in all directions, and this wind carries a magnetic field that spirals as the sun turns, filling space with a low-density warm plasma. The wind meets the thin gas that drifts between stars, and where the two pressures balance a boundary, forms an outer shell that marks the edge of the sun's direct influence. Two small spacecraft launched by the National Aeronautics and Space Administration travel outward on steady paths, and each has crossed that boundary after a journey of many decades, finding beyond it a calmer sea where the interstellar medium flows around the sun's protective bubble. Inside the boundary, the wind slows and the field lines drape. Outside, the density and energy shift to the character of interstellar space. He imagines this interface not as a wall, but as a slowly breathing surface that moves slightly as the sun's own cycle rises and falls over periods of about 11 years, and the thought is soothing because it turns a harsh edge into a living membrane. The path inward passes the scattered disk where objects on inclined and elongated orbits mark a history of past interactions, and then reaches the main belt beyond Neptune, where the dwarf planet with a heart-shaped plane circles in harmony with Neptune's period, a relation that lets both hold their orbits without close approach. The New Horizons spacecraft sent by the National Aeronautics and Space Administration has flown through this region, returning the first close views of that dwarf planet's varied surfaces, soft plains of nitrogen ice, rugged mountains that may be built of water ice as strong as rock in that cold, and hazes that rise and settle with the weak sunlight. After that encounter, the spacecraft continued on to a smaller contact binary, a snowman-shaped object that appears to have formed from two pieces that gently joined, and this calm union fits the slow dance expected in places where collisions are rare and motions are modest. He thinks about the chemistry of these outer bodies as a kind of deep freeze that preserves early ingredients. Methane, nitrogen, carbon monoxide, and water ices sit together in layers, and sunlight, though weak, slowly alters their uppermost grains through a process that turns simple molecules into complex reddish organics that darken the surface. Where fresh ice is exposed by small impact or slow glacial flows, the surface brightens. Where time has passed without disturbance, the hue deepens. This cycle is unhurried and reassuring because it ties colour and reflectivity to exposure in a way that instruments can read. He considers the slow traffic that brings some of these bodies inward as comets, When an object from the distant belt or cloud is nudged onto a path that dips close to the sun, the warmth encourages ices to sublimate directly into gas and dust that was mixed into the ice is free to trail behind, forming a tail that aligns with sunlight and the solar wind. The outgassing can gently push on the nucleus, changing its orbit by tiny amounts over many passages, and the result is a record that is audible to instruments as a slow evolution rather than a sudden jump. The comets that return on short schedules are likely kin to the belt beyond Neptune, while those that visit only once or after many thousands of years likely come from the deeper spherical cloud, and this division makes the population into two overlapping families, both steady and both instructive. He imagines how the outer belt keeps its order through shepherding resonances, and how Neptune's slow migration outward early in solar system history would have led to captures into these resonances, trapping many objects into stable patterns that continue today. Computer models that evolve many small bodies under the gravity of the giant planets produce structures that look like those observed, with concentrations at particular periods and gaps at others, and this fit between model and sky carries a calm satisfaction. The thermal environment shifts gently with distance. At the belt beyond Neptune, sunlight is weak, but still capable of warming the most volatile ices enough to creep flow and refreeze, especially when seasonal illumination changes the balance over long years. Farther out in the deep cloud, everything rests in darkness so complete that only the occasional distant star or the background glow offers any light, and there the chemistry slows to a near halt. He rests on the image of a tiny world turning slowly in that darkness, its surface hard and quiet, its orbit a long oval that will not bring it near the sun for time spans longer than recorded human history, and the thought is restful, because it places daily concerns within a broader and calmer clock. He notes that the sun's magnetic field and wind also shape the inward journey of small charged dust and the path of high-energy particles from distant sources. The field guides particles into gentle arcs and funnels some toward the polar regions of planets that carry their own fields, while the wind carves a wake in the interstellar medium like the wake of a ship that moves through still water, except the scale is so large that the structure hardly changes over a human lifetime. Instruments that ride on outward-bound spacecraft record the slow shift in particle populations as they near the edge, marking the boundary not with a sharp click, but with a smooth change that confirms a mental picture drawn from models and then coloured by data. He brings the view finally to the quiet fact that the outer solar system is not empty, but gently occupied by billions of small bodies whose collective gravity is minor, yet whose presence holds the memory of formation. In their orbits live the echoes of encounters with the giant planets. In their surfaces rest the slow work of sunlight. In their distribution persists the imprint of ancient migration. The whole scene is peaceful, and the peacefulness comes not from stillness, but from rhythm resonances that keep time, a wind that flows outward in a steady breath, an edge that moves with the sun's cycle, and a shower of comets that appear brighten and fade on schedules that can be predicted long in advance. He keeps this rhythm as he turns his attention toward the next layer inward, where the sun's breath becomes a felt environment with waves and boundaries, and where spacecraft trace arcs through a medium that is sparse but lively enough to show its pattern to any patient instrument that is willing to listen. He turns his attention to the sun's long breath, a continuous outflow of charged particles that streams outward in every direction and fills the space between the planets with a thin, warm wind, and he feels the comfort of its steadiness even as small variations ripple through it like gentle waves upon a broad lake. At the surface of the Sun, magnetic fields arch and twist above a bright hot atmosphere called the corona, where temperatures climb to many millions of degrees and give particles the energy they need to escape gravity's grasp. As these particles flow outward, they carry the Sun's magnetic field with them, and because the Sun turns, the field winds into a graceful spiral that extends through the solar system, a pattern first described as a simple, beautiful curve and later traced directly by patient spacecraft. The outflow is not uniform, yet its differences are reliable and soothing to study. From regions where magnetic field lines open broadly into space called coronal holes, faster streams emerge and overtake slower streams from elsewhere, and their meeting forms long-lived interaction regions that rotate with the Sun and can be sensed far from the source. The wind also bears waves that travel along the magnetic field, ripples in velocity and direction that spread energy without violence, and these waves help explain how the corona remains so hot and how the wind accelerates gently away from the Sun. Instruments aboard the Parker Solar Probe sent by the National Aeronautics and Space Administration fly closer to the Sun than any craft before it, dipping through the birthplace of the wind and sampling the magnetic switchbacks and the fine structure of the flow, while the Solar Orbiter, a mission of the European Space Agency, working with the National Aeronautics and Space Administration, watches the glowing surface and the inner atmosphere and measures the particles farther out, linking images and in situ data into a single unhurried story. Together, these explorers do not discover a storm so much as a living breeze, one that waxes and wanes with the roughly 11-year solar cycle, grows more structured as the Sun wakes toward its active times and calms as it drifts back toward quieter years. He lets the notion of a current sheet settle into view, a vast thin surface where the magnetic field carried by the wind changes direction, folded into a slow undulation that sweeps past the planets in a rhythm set by rotation and the changing shape of the corona. When the current sheet passes a spacecraft, the magnetic polarity flips like the soft turning of a page, and the regularity of these flips offers a clock by which the inner heliosphere keeps time. Embedded within the wind are occasional ejections of denser plasma and stronger fields from the corona, but even these, which can drive shocks and compressions, fit within the wider pattern of a system that resists chaos by dispersing energy across distance and time. Near Earth, the wind meets the planetary magnetic field and flows around it, shaping a long wake and a compressed dayside, and the changing pressure and field orientation set the stage for auroras that will later glow in high latitudes, a visible, softly moving edge of the Sun's influence that does not break the calm of the larger story. Farther out beyond the orbits of the giant planets, the wind continues until it slows at a broad boundary, called the termination shock, where the outward speed drops below the speed of waves that carry information through the plasma, and beyond this region lies the heliosheath, a warm, turbulent envelope where the solar wind mixes and prepares to meet the interstellar medium. The two Voyager spacecraft sturdy messengers launched by the National Aeronautics and Space Administration many decades ago have crossed this region and entered the space between the stars where the solar wind no longer dominates, and their instruments have recorded smooth changes in particle populations and magnetic field direction that together mark the outer border known as the heliopause. The shape of this border is set by the balance between the wind's pressure and the pressure of the interstellar medium flowing slowly relative to the Sun, and it likely stretches into a gentle tail downstream, while rounding into a blunt nose upstream, a form mapped indirectly by energetic neutral atom, imaging from missions such as the Interstellar Boundary Explorer, which senses atoms created when charged particles exchange electrons and travel in straight lines back toward detectors. The picture that emerges is serene, a protective bubble that breathes with the solar cycle, swells and shrinks modestly, and turns aside many of the highest energy particles that roam the galaxy, thereby reducing their number near the Sun and modulating their arrival at Earth. He appreciates how this modulation is not a switch, but a filter whose strength changes slowly, and how measurements of cosmic rays over decades show a rhythm in step with the Sun's own changes, a rhythm that needs no dramatic explanation, only a clear accounting of fields and flows. The wind also carries dust and larger grains into new arrangements. Some grains feel the drag of the plasma and spiral inward slowly. Some are pushed outward by sunlight. Some become charged and follow field lines into arcs that instruments can map. The New Horizons spacecraft, having journeyed past Pluto, continues to count dust impacts and measures a nearly constant background with gentle enhancements, where the orbits of comets and small bodies add contributions, and these patterns mirror the quiet migration and slow grinding of countless tiny sources. Pickup ions add another layer to the story. Neutral atoms from the interstellar medium slip into the heliosphere, become ionized by sunlight or by charge exchange, and are then picked up by the magnetic field of the wind riding along and adding heat and pressure to the outer regions. They reveal themselves in subtle changes to the distribution of particle energies and in faint emissions of energetic neutral atoms, and together they help outline the transition from solar domain to interstellar neighborhood. He returns to the inner regions where magnetic structures near the Sun imprint their patterns on the wind. Close to the surface, supergranular flows shuffle the footpoints of magnetic field lines, braiding and unbraiding them in slow motions that release packets of energy. Some field lines open outward and guide plasma into the wind. Others close back to the surface and confine loops that glow in ultraviolet and X-ray light, and the balance between open and closed lines shifts over the solar cycle as polar coronal holes grow and shrink, and as the global magnetic dipole tilts and then reverses. These changes alter the pattern of fast and slow wind, but they do so in a manner that remains readable, and predictions of the wind's structure along the path of spacecraft improve as synoptic maps of the solar surface accumulate and as models compare their outcomes with in situ measurements. He muses that the wind's evenness is not the same as sameness. Like a river that keeps its level while ripples play upon its surface, the solar wind maintains an overall flow while carrying a detailed record of its birthplace, in the curvature of its field lines, the composition of its ions, the ratios of elements that were frozen into the corona at their source temperatures, and the minor waves and discontinuities that mark boundaries between streams. It is a medium that rewards patient listening because each small feature is a clue placed gently in the flow. He lets speculation remain measured and grounded. The exact mechanism by which the corona is heated and the wind accelerated likely involves a mixture of waves that dissipate at small scales, interchange reconnection that opens and closes field lines and nanoflares too small to see directly, but numerous enough to matter. He does not claim a single cause, but appreciates how the suite of processes together can sustain a steady outflow. He closes this section with the image of the heliosphere as a great softly breathing cocoon luminous near the Sun, and transparent far away, its boundary defined not by walls, but by balances, its interior threaded by a spiral that links every planet to the source, and its breath washing gently over worlds and ring systems and small drifting bodies, with a continuity that invites rest. The same breath that bends around Earth and paints the night with quiet auroras also stretches beyond the giant planets and meets the galaxy with a polite bow, and in that exchange the solar system shows itself as both sheltered and connected, a calm vessel moving within a broader sea. He listens to the planets as if to a set of well-tuned clocks, each keeping its own measure, yet all joined by gentle arithmetic into a larger harmony, and he finds that the solar system moves not with noise, but with recurring returns that promise calm predictability. Each world traces an oval path around the sun, and from these paths come periods that can be read like hours and days a year for each planet, a day for each rotation, and longer cycles when small tugs accumulate to shift the orientation of the orbits with a pace almost too slow to sense. Between these clocks lie simple ratios that steady the whole. A dwarf planet beyond Neptune shares a 3-to-2 rhythm, with that giant completing 2 orbits in the time Neptune completes 3, so that when their paths cross in space, their timing avoids close approach. The 3 inner large moons of Jupiter lock into a chain that repeats with elegant precision. The innermost completes 2 laps for every one of the middle, and the middle completes 2 laps for every one of the outer, and the pattern keeps their positions in a dance that both stabilizes and excites their tides. The belt of small rocky bodies between Mars and Jupiter carries its own set of absences gaps that appear where orbits would match simple ratios with Jupiter, and thus suffer regular nudges that lead to removal, and these quiet missing lanes reveal resonance as a sculptor of populations. He notices that resonance can protect as well as clear. At certain angles along a planet's orbit, a gravitational balance forms points where small bodies can share the same year, and swarms gather there as patient companions. Their presence is more like a cloud in step than a threat, because the geometry keeps them from wandering near the planet except through slow collective shifts. The rhythm of spins and orbits adds another layer. Mercury, the innermost planet, turns 3 times for every 2 circuits of the Sun, an unusual but stable compromise between the pull of tides, the planet's elongated shape, and the changing speed of its orbital motion near and far from the Sun. Many moons keep the simple 1-to-1 lock, showing the same face to their planet, while their interiors stir with heat from tides that wax and wane as they move along not quite perfect circles. Seasons arise from axial tilts that lean planets toward and away from the Sun during their orbits, and the lengths and strengths of these seasons become predictable cycles that repeat with a steadiness that invites trust. Over longer spans, slight changes in tilt orbit shape, and the timing of seasons relative to closest approach to the Sun generate slow climate rhythms on Earth patterns that unfold over tens of thousands of years and leave layered marks in ice and sediment, and these rhythms remind him that even what seems varied rests upon clocks that keep time across ages. Conjunctions occur when planets line up in the sky as seen from Earth, and their recurrence can be predicted with quiet confidence. The intervals between these meetings, called synodic periods, are set by the difference in orbital speeds, and the pattern repeats with a cadence that felt like certainty to early astronomers who had only their eyes and careful records. Eclipses and transits are rarer alignments made precise. When Earth, Moon and Sun form a straight line, the shadow cast by one crosses the other, and the sky darkens in daytime, or a distant face takes a small dark bite from a brilliant disk. And just as predictable are the transits of inner planets across the Sun, events that come in pairs separated by 8 years, and then do not return for more than a century. These special moments are dramatic to see, and gentle in their arithmetic, because the geometry that allows them is plain, and the same simplicity extends to worlds beyond the solar system, where a planet passing across the face of its star causes a slight dimming that repeats exactly on schedule as long as the orbit remains steady. Missions such as the Kepler Space Telescope and the Transiting Exoplanets Survey Satellite collect long strings of these small dips, and the intervals reveal not only the length of the year, But when multiple planets are present, the slight shifts caused by their mutual tugs timing variations that act as whispers of masses and resonances. He appreciates how the solar system's harmony includes slow adjustments rather than strict permanence. The orbits precess meaning their ellipses turn very gradually, and their planes tilt a little over time relative to a common reference. These motions are tiny in any human span but become smooth cycles when traced across millions of years. The gravitational conversation among the planets remains polite, and the totals of energy and angular momentum keep the set within bounds. Simulations that let planets pull on one another under known laws produce the same family of secular rhythms seen in data, and the fit between models and measurements makes the whole system feel like a collection of clocks on a shared wall, each one accurate on its own, yet also keeping a family time. He rests on the grace of Lagrange points places where the pull of a planet and the sun together make a frame in which a small body can hover or orbit with little effort. Spacecraft find these regions hospitable for continuous watching, and swarms of ancient companions share them as quiet neighborhoods. The existence of such points is a statement about the geometry of gravity, and the reality of their occupants confirms the same steady picture from another angle. He finds calm in the way subtle effects are folded into this order without breaking it. Radiation from sunlight can push tiny bodies and slowly change their paths over long periods, and when this drift brings an object toward a resonance, it may be captured and then shepherded into a new orbit, a gentle migration that reshapes belts and rings. The tug of tides can exchange spin and orbit energy between a planet and its moon, moving the moon outward, while the day lengthens and the rates are measurable in small but consistent increments that accumulate like sand in an hourglass. Even meteor showers follow predictable calendars because they arise from Earth-crossing trails of dust left by comets, and those trails are maintained by slow processes that can be charted with care. He lets the open questions hover without disturbance. The exact path by which the early solar system settled into its present harmony likely included migrations and resonant captures among the giant planets, and while models differ in detail, many versions yield populations and arrangements similar to those observed today. The solar system's present layout therefore feels like the natural result of gentle adjustments, guided by sturdy rules rather than a fragile accident. He returns to the image of a night sky marked by slow movements. Planets creep against the star's loop in retrograde as Earth passes them, or is passed, and then resume their forward motion. The pattern is steady, and can be followed with a notebook and a patient eye. The predictability does not remove wonder. It deepens it because knowing that a point of light will return to a given place on a given night connects experience to a larger rhythm that does not strain. He closes this segment by hearing the solar system as a lullaby of periods, years that differ, but relate spins that lock or resonate lines, that return shadows that recur, and seasons that come and go with dependable grace. The same logic that keeps a dwarf planet safe, in step with Neptune, a trio of moons linked around Jupiter, and a belt sculpted into gaps by a giant's influence, also extends to worlds around other stars, where repeating dips and gentle timing shifts tell of many systems of clocks. The harmony is not the result of perfection but of balance, a sum of tugs that finds repeating patterns and settles into them, and in that settling the solar system offers a sense of time that soothes a reminder that motion can be both complex and restful when it runs by rules that have room for return. He turns to the ocean worlds, quiet moons that carry seas beneath ice and keep their chemistry moving in darkness, and he lets their evidence gather like ripples that meet and pass without haste. Around Jupiter, the moon Europa circles with a surface of bright, grooved ice, marked by long lines and a youthful sheen from frequent renewal. And beneath that shell lies a global ocean, kept liquid by tides that flex the interior as the moon moves along an ellipse sustained by resonances among the larger moons. The Galileo spacecraft sent by the National Aeronautics and Space Administration measured magnetic signatures near Europa that fit the presence of a salty conductive layer below the ice, and images showed places where ridges split and refroze, as if warm water had reached near the surface and then settled back, leaving faint stains of salts and simple organics. On Europa, the energy comes not from sunlight but from stress, and release a cycle driven by gravity, and in that cycle minerals from a rocky floor may meet oxidants made at the surface by charged particles closing a slow loop that feeds chemistry across the dark sea. Farther out around Saturn, the small moon Enceladus offers a more direct view. The Cassini spacecraft, a mission led by the National Aeronautics and Space Administration, with partners including the European Space Agency and the Italian Space Agency, flew repeatedly through geyser, like plumes that surge from long south polar fractures, and the instruments tasted water vapor, tiny grains of ice salts, simple organics, and hydrogen gas. That hydrogen points to warm rock and water reacting in a process called serpentinization, where minerals absorb water and release hydrogen that can feed microbial metabolisms on Earth, and the grains collected in the deep Saturnian ring showed small silica particles that form at high temperatures, another sign of hydrothermal vents beneath the ice. The south pole of Enceladus stays active because tides focus stress along those great fissures, opening and closing them with a rhythm tied to the orbit, and heat flows outward in patterns that match the rate of venting. Here, in a body not much wider than a large mountain range on Earth, a full ocean lies below a thin shell, and water, rock and chemical energy meet in a quiet, long-lasting union. Titan, the largest moon of Saturn, keeps a different secret. It holds a thick nitrogen atmosphere with clouds and rain made of hydrocarbons. Rivers that carve channels and lakes and seas at the poles, while beneath its icy crust likely lies an interior ocean, rich in ammonia and salts that lower the freezing point. Radar and gravity measurements from the Cassini mission showed subtle changes in rotation, and tides that fit a decoupling between the shell and the deeper interior, and surface shapes shifted in ways that favor an inner sea. The chemistry on Titan's surface is cold and slow, forming complex organics that settle like soft snow, and these grains may cycle downward over time into the crust, where they might meet warmer water in pockets, along fractures turning surface air chemistry into subsurface solution and setting up patient reactions. Ganymede carries its own field of magnetism, a sign of a warm interior, and evidence from magnetic measurements and auroral motions as recorded by the Hubble Space Telescope suggest a deep ocean, sandwiched between layers of high-pressure ice. Callisto darker and older may also harbour a buried sea, inferred from the way Jupiter's changing field induces a response that only a conductive layer can provide. He gathers these worlds into a family of oceans that do not need sunlight to stay alive with motion. Tides supply heat over deep time radiogenic elements, add a steady warmth, and antifreezes like salts and ammonia extend liquid ranges. Rock at the ocean floors supplies elements and fresh surfaces, and the balance between oxidants delivered from above and reductants delivered from below provides a gradient that can power slow chemistry. Instruments continue to listen. The Juno spacecraft, now circling Jupiter, maps gravity magnetic fields and dust environments that frame the moons and close passes, refine sizes and internal structures. The Europa Clipper, a mission of the National Aeronautics and Space Administration will fly many times by Europa to survey the ice shell, measure the ocean's salinity and depth by induction, and radar soundings and map places where the shell might be thinner or more recently active. The Jupiter Icy Moons Explorer from the European Space Agency travels outward to focus especially on Ganymede, while also studying Europa and Callisto, and together these missions will turn outline into portrait. He keeps the talk of habitability gentle and grounded. Liquid water is present, energy is present, time is abundant, and the basic elements known to build complex molecules are measured directly. On Earth, microbial communities thrive around vents that release heat and minerals into deep oceans without light from the sun. And while no claim is carried across the gap, the analogy provides a calm reminder that essential transactions can proceed wherever gradients persist, and structures allow concentration. He notes that even without biology, these seas are serene engines that reshape their shells. Convection in warm water can move heat toward the ice, creating bands of thinning and pockets where the shell may crack and admit fresh water upward to freeze building ridges, domes, and chaos terrains in slow episodes that later relax. Crystalline structures in the ice, the presence of clathrates that trap gas, and the migration of salts through porous layers all build textures that a spacecraft can read by light and by radar. Each feature locks to a process with a pace measured in thousands or millions of years, and the sum of them is a surface that changes without haste. Pluto's smooth plain of nitrogen ice shows slow convection cells and young surfaces beside rugged water. Ice mountains and models of heat and composition allow a buried ocean that stayed liquid beneath insulating layers. Ceres in the main asteroid belt shows a bright salt deposit in a deep crater where brines likely reached the surface in the recent geological past, and gravity and shape together hint at a relaxed interior where water once moved. These small worlds, like the larger moons, carry a memory of warmth held gently and released slowly. He weighs the open questions without hurry. How thick are the shells and how quickly do they cycle? How much energy reaches the ocean floors and how varied are the rock types? Do plumes rise only in certain orbital phases, and do they sample a deep ocean or a shallow pocket? What is the balance of oxidants made at the surface by sunlight and charged particles and delivered downward through cracks, compared with reductants rising from rocks through water? Answers will come as instruments map fields, taste grains, listen for heat and image the night sides where faint auroral glows trace magnetic paths. He ends with a calm image. Beneath miles of ice, a dark sea turns slowly, touched by tides that knead the shell and stir the deep, warmed by stones that still whisper heat, fed by salts that drift and settle, and visited now and then by a plume that carries a spoonful of the ocean into empty space. Nothing in this scene demands haste. The moons keep their orbits and their cycles, the chemistry follows gradients as patient as the turn of seasons, and the instruments that pass will add their notes to a growing gentle record. In those notes, the tale of hidden oceans becomes not a rush for discovery but a lullaby of water, rock and time. He turns to rings and dust, to places where countless small collisions proceed without alarm, and where gravity and light together shape structures as delicate as lace spread upon the darkness, and he finds calm in the way gentle impacts do more arranging than destruction. Around Saturn, the broad rings shine with a brightness that comes from clean ice, and from the constant stirring of moonlet's grains and faint vapour, and the Cassini spacecraft from the National Aeronautics and Space Administration with partners trace their textures for many years, revealing spirals, edges and waves that move as slowly as the hands of an old clock. Near sharp gaps, shepherd moons hold boundaries by trading energy with ring particles, one moon pulling a little ahead and one a little behind, so that the particles between remain confined and the resulting edges look crisp, because the exchanges repeat with every circuit. Spiral density waves roll outward from resonances with larger moons farther away, and these waves carry information about the ring's mass and temperature, the way ripples on a pond carry news of a tossed pebble. Vertical waves arise when the plane of particles is tilted by a gravitational nudge, lifting and lowering the ring into a gentle corrugation that a long shadow at low sun reveals like a fine comb. He lingers on how every feature has a period and an explanation that invites unhurried reading. Narrow gaps align with simple ratios between the time a particle takes to circle and the time a moon takes, and within those gaps small clumps sometimes appear and vanish, as if the ring briefly considered stitching itself into larger forms before the background shear pulled them back into threads. Near the equinox of Saturn, when sunlight crosses the ring plane at a shallow angle, even subtle vertical structures cast tall, thin shadows across the ring face, making visible the delicate ripples and the temporary hills lifted by passing bodies, and the view makes the otherwise invisible dimension feel present without noise. The material in the rings grinds slowly, for grains collide and shatter, then stick again, then erode under the faint rain of micrometeoroids, and the net exchange keeps particle sizes within a narrow distribution that shifts only over long spans. Over time, light itself influences the grains through radiation pressure and through a gentle drag that causes small particles to lose angular momentum and spiral inward, called the Poynting-Robertson effect, and this inward drift adds to the slow exchange between rings and moons. The E-ring of Saturn spreads far and faint, supplied by the south polar plumes of Enceladus that lift tiny grains into space. Those grains follow orbits that fan widely, and then over years fall inward, creating a halo that tells a quiet story of steady venting, smooth motion, and gentle loss. Other giant planets keep their own spare rings. Jupiter's rings are thin, dusty, and replenished by impacts on small inner moons that loft new grains to join a graceful faint band. Uranus carries a set of narrow, dark rings rich in larger boulders and sharply confined by shepherds, their revealed geometry a statement of a system held in place by exact resonances. Neptune keeps arcs within a wider ring stable segments, gathered by the presence of Galatea, a moon whose gravity corrals particles into places where they can persist, and the arcs appear and fade with a breath-like rhythm that models capture when they include the soft balances among moon's particles and resonances. He extends the view beyond the planets to the dust that fills the inner solar system as a broad, thin cloud, seen before dawn or after dusk as a soft triangle of light. This zodiacal glow comes from sunlight scattered by tiny grains that occupy orbits of many shapes and sizes, and the brightness gently declines with distance from the sun. The grains come from slow grinding in the asteroid belt and from comets that shed dust as their ice is warm. They drift inward over many thousands of years, and along their paths they can be trapped temporarily in resonances with Earth or other planets, leaving subtle bands and wakes that spacecraft detect as faint increases in dust impacts. The same quiet processes that arrange the zodiacal cloud also shape thin rings of dust around Mars and the Earth, where trapped particles form weak enhancements that instruments register with patient counting. He considers that collisions under low gravity rarely smash so hard that nothing remains. More often they chip, fracture, and sometimes fuse, and the average outcome is neither growth nor loss, but a slow cascade that feeds small sizes from large, while light and drag, remove the smallest a steady state that can hold for long periods. Collisions in rings occur at low speeds because neighbouring particles share almost the same orbit, and so the many meetings smooth the structure rather than destroy it like beads sliding against one another as a strand flexes with motion. He feels the serenity of timescales layered across the system. Orbital periods set a fast rhythm measured in hours or days. Wave patterns drift over months. Migration due to drag and resonant exchanges unfolds over thousands to millions of years, and the slow evolution of a ring's total mass takes place over tens of millions to hundreds of millions of years, depending on the balance of sources and sinks. The solar system therefore provides a full set of calm metronomes from which to choose each ticking at a rate that suits a different aspect of the dust and rings. He rests briefly on debris disks around other stars, wide belts of dust and small bodies that shine in the infrared and appear in high-resolution images as rings with gaps, warps, and off-center shapes. The Atacama Large Millimeter Array has drawn such disks as smooth ellipses with narrow dark bands that likely mark where planets have cleared lanes or gathered particles into resonances, and the Hubble Space Telescope and the James Webb Space Telescope have revealed dusty arcs and swept backs that hint at planets that cannot yet be seen directly. These distant structures behave as our rings do, but on larger scales, affirming that gentle collisions, light pressure and gravity write the same phrases in many places. He keeps open questions at a soothing distance. The total age of Saturn's bright rings remains debated. Their clean ice could be youthful, or their surfaces could be renewed by processes that clean them faster than micrometeoroids darken them, and long-term measurements of mass meteoroid influx and grain composition continue to narrow the range without forcing a conclusion. The origin of some narrow arcs and waves admits more than one pathway, and each pathway is being tested through comparison with data and with models that do not rush their parameters. He returns to the image that best holds the feeling. A field of particles orbits together in a plane shepherded by small moons, stirred by passing resonances decorated with waves and shadowed ripples, each grain tracing a path set by gravity and light, each collision a soft negotiation that shares momentum and heat until the local patch settles back into its strip of the grand design. The night side of a ring gazed upon near equinox shows thin lines standing like reeds, a temporary relief that vanishes as the sun climbs, and the day side glows with a brightness that changes with viewing angle, because countless surfaces scatter light in unison. Beyond the rings, a faint glow from the zodiacal cloud surrounds the inner planets, and forms a serene backdrop for their motions. Nothing in this scene insists, everything repeats. The result is a stable architecture whose changes announce themselves in cycles, and whose surprises come as new waves rather than breaks. He carries forward the sense that dust and rings represent the universe's willingness to make beauty from the smallest pieces through the simplest rules, and he lets that willingness guide the turn toward the slow messengers that travel along stretched paths from the outer dark to the inner light, leaving tales that write their temporary letters across the sky and then fade with the same gentleness that created them. He welcomes the comets as slow messengers, small and ancient bodies that carry records of the early mixture from which the planets formed, and he watches them move along long-stretched paths that turn inward for a time, and then retreat to deep cold, their visits brief but predictable on clocks that measure lifetimes and epochs. Each one is a fragile blend of water, ice, frozen carbon dioxide, frozen carbon monoxide, ammonia, and dust rich in carbon and silicates, bound together in a porous structure that releases gas when warmed, and so grows a temporary coma, a hazy envelope that makes a tiny nucleus appear large. Sunlight and the solar wind shape that haze into two main tails, a pale dust tail that curves along the orbit, and a straight ion tail that points away from the sun, guided by magnetic fields carried by the wind. Sometimes a faint third tail made of sodium appears as a delicate thread, and sometimes streamers and rays mark the places where jets erupt from patches warmed by day. He considers their families. Short-period comets that return in decades often trace their origins to the belt beyond Neptune, and are guided into Jupiter-family orbits that bring them back again after a handful of years, while long-period comets arrive from a far spherical cloud that surrounds the solar system, their periods so great that a return will not occur within the span of human record. Both families carry the chemical memory of the early disk, and the distinction between them is a difference of storage and stirring rather than nature. He lets mission results lay themselves out with quiet clarity. The European Space Agency's Rosetta spacecraft travelled alongside Comet 67P and released a small lander that touched the surface, and the instruments found a dark crust with patches of brighter ice, a mixture of dust and volatile ices that release gas through fractures as sunlight moves across the spinning shape. The ratio of deuterium to hydrogen in its water vapour was higher than in Earth's oceans, a calm hint that this specific population may not have supplied most of Earth's water, though other comets could hold different ratios. The National Aeronautics and Space Administration's Deep Impact sent a copper mass into the nucleus of Comet Tempel 1 and watched the plume revealing soft fine materials and a mantle of dust that likely formed as more volatile ices sublimated and left grains behind, and years later another flyby saw the crater matured and the surface changed in small ways by continuing erosion and fall back. The Stardust mission flew through the coma of Comet Wild 2 and returned particles to Earth in aerogel and laboratory studies, found fragile aggregates, minerals that had formed at high temperatures in the inner disk, and organics that had remained cold evidence that the early solar system mixed materials across great distances before they settled into the present order. The epoxy extension of Deep Impact watched Comet Hartley, 2 Puff, with carbon dioxide-driven jets that lifted pebbles and snowballs, showing that not all comets behave the same, and the Giotto spacecraft flew by Halley's Comet and recorded a dark, rough nucleus with jets rising from sunlit patches. These visits, measured each in a different way, confirm that comets are not inert stones, but living ice-dust mixtures that respond gently to light, their surfaces evolving, with each pass their spins shifting by small amounts as jets push. He rests on the idea of non-gravitational forces with ease. When a nucleus outgasses, the reaction gives a small push that alters the path ever so slightly, and over many returns the accumulated change becomes clear as a drift forward or backward along the orbit. The effect is not random. It follows the pattern of activity, and observers who have recorded many apparitions can fit the shift with calm parameters that improve predictions without forcing the sky to comply. He listens to meteor showers as echoes of comets, streams of dust shed along orbits that Earth crosses on the same weeks each year. The Perseids trace their source to a long-period comet that returns on a schedule measured in more than 100 years. The Leonids come from a different parent that returns in a similar span and can produce storms when a fresh trail passes close. Other showers arise from younger and older streams laid down by comets that continue to add to their lanes each time they near the sun. The grains that touch the atmosphere burn in swift streaks that sketch the origin point in the sky, and the yearly recurrence of these displays, known to careful record keepers long before the physics was detailed, affirms the quiet durability of the source orbits. He thinks about colour and reflectivity. Comet nuclei are dark, often reflecting only a small fraction of the light that falls upon them, because their surfaces are mantled by complex organics and dust, with fresh ice, appearing only in patches after a fall or along new cracks. The darkness does not mean heat, it means absorption and re-radiation at longer wavelengths that instruments can measure, and the maps of temperature and composition combine to reveal where jets begin and how they move with day and night. He imagines a nucleus spinning in a few hours to a few tens of hours, its shape irregular like a contact binary, or a rounded potato. Its spin states sometimes change by torques from uneven jets, its tumble damped over time by internal friction into a simpler rotation. He keeps the rare fragments and collisions in mind without letting them disturb the calm. Comets sometimes split either from thermal stress spin-up or tidal forces in a close passage by a planet, and the fragments trace parallel orbits for a while before dispersing. One line of fragments once fell into Jupiter and left fading marks in the planet's upper atmosphere, a dramatic testimony that the same gentle rules of gravity can focus a rare encounter into a visible event, yet even this happened with warning from orbits calculated many months in advance. He turns to the chemistry carried by these slow messengers. Mass spectrometers and remote spectra reveal water, carbon monoxide, carbon dioxide, methanol, ammonia, hydrogen, cyanide, formaldehyde, and more complex organics as well as noble gases and the ratios of isotopes in several elements. The mix varies from object to object, and the pattern of release changes with distance, and with the season of the comet's spin axis for geometry, determines which patches warm and which remain cold until later in the orbit. Dust grains show crystalline silicates that formed close to the infant sun and were later lofted outward into cold storage, a sign of broad circulation in the early disk, and these silicates share the coma with fluffy aggregates that likely formed in gentle sticking collisions in shaded regions. He notices how comet studies and models of early Earth's supply of volatiles now meet in a measured way. Water likely came from a mixed set of sources including hydrated minerals in small bodies that formed near the present orbit of Jupiter, and comets contributed some fraction, alongside these asteroidal sources, with the exact mix, still a topic of gentle refinement as isotope ratios accumulate across populations. He appreciates that surveys continue without haste. Telescopes that scan the sky find new comets at a steady pace, record their brightness changes, measure their colors, and estimate sizes from thermal emission, while spacecraft near the sun monitor the frequent small sun grazers that skim the corona and often evaporate, adding slight material to the inner wind. Patterns emerge, the number of small long-period comets is high. The distribution of sizes follows a slope that suggests ongoing fragmentation, and the rate of arrival varies with the paths by which distant bodies are nudged inward, by slow tides from passing stars and by the galactic field. He lets open questions remain as invitations rather than alarms. How deep do dust mantles grow before activity relocates to new fissures? How much interior layering records episodic activity in past orbits? How widely do isotope ratios vary among different reservoirs in the distant cloud and the belt beyond Neptune? What role do spin changes play in turning dormant bodies active again? Answers will keep arriving as detectors improve and as new missions sample more of the diversity. He ends with a quiet image of a comet leaving perihelion and fading. The coma contract's jets sputter and rest. Frost refreezes upon shadowed walls, and the nucleus returns to deep cold with a slightly altered spin and a slightly changed path carrying its messages back into the dark until a future return. Nothing is lost. The dust left behind becomes a trail that assures a meteor shower. The gases join the wind and disperse, and the nucleus waits with patience that matches the slow clock of its orbit. The messenger keeps time with the solar system, and in doing so adds a soft voice to the larger choir of cycles that have guided the story from the start. He turns his attention to Earth's subtle signals of space, the quiet ways the sky touches the planet's calm routines, and he lets the evidence arrive as soft light's faint trails and gentle changes that repeat with dependable grace. In high latitudes, auroras unfurl as curtains and arcs that move without hurry, their colours drawn from atoms and molecules in the upper air that glow, when charged particles guided by Earth's magnetic field drift down along invisible lines. Oxygen at heights near 200 kilometres releases a pale green, and higher. Still it offers a deep red when collisions are rare, while nitrogen molecules add blue and violet at lower reaches, and together these tones paint ovals around each magnetic pole that expand and contract with the pressure of the solar wind. The power behind the display comes from the magnetosphere, a vast region shaped by the meeting of Earth's magnetic field and the wind that flows from the sun, and though the magnetosphere stretches and breathes, it does so with rhythms that can be followed by satellites and ground stations that measure slow changes in field strength and direction. During quiet times, energy trickles in and releases in small substorms that brighten the auroral arcs for an hour or two. During more active periods, when the sun sends a stronger parcel of magnetic field, the oval grows and moves toward mid-latitudes and currents close through the upper atmosphere as a soft, wide ring that later relaxes, leaving a record written in indices that long-time series keep. Above the weather, the ionosphere forms in layers as sunlight knocks electrons from atoms and molecules, making the air conductive in bands that rise during day and settle during night. The lowest layer absorbs distant radio waves during daylight and fades after sunset. Higher layers persist refracting radio, so that signals can bend beyond the horizon and return a property that once stitched continents together with voices, and now serves as a medium for patient probing of winds and waves. Instruments on the ground by bouncing pulses upward and listening for the echo chart, the altitude and density of these layers, and over a solar cycle of about 11 years, they see daily patterns lifted higher during active times and lowered during quiet times, a breathing that is regular enough to hold in memory. Meteors sketch brief lines that tell of slower processes. Each night Earth moves through a rain of small particles left by comets and broken asteroids, and most grains burn softly between 80 and 100 kilometers up, leaving glowing trails that last for seconds and fine metallic atoms that drift to become part of a persistent layer in the upper atmosphere. Radars see those trails as lines that reflect radio waves, and by counting their echoes, observers learn the speed and direction of the small bodies that feed them, while laboratory collections of micrometeorites gathered from clean snow or ocean sediments show rounded grains of iron and silicates that turned in flight and cooled in air, a calm delivery of extraterrestrial dust that adds measurable mass to Earth each year without fanfare. In summer, at high latitudes, noctilucent clouds appear at the edge of space, silvery veils that shine after sunset when sunlight still reaches the high mesosphere. They form from tiny ice crystals that condense on the very dust contributed by meteors at temperatures far below the familiar cold of weather clouds, and their thin ripples move with waves that propagate upward from the lower atmosphere, linking ground and space through a ladder of motion. Even darker than aurora and rarer than noctilucent clouds, sprites and halos flash above thunderheads, brief electrical blooms that tie the lower weather to the edge of space, their occurrence shaped by the fields that storms build and by the background conditions of the ionosphere. The upper air also glows on the clearest nights with a gentle widespread light called airglow, born from chemistry that recombines oxygen atoms split by sunlight and from excited hydroxyl at the top of the mesosphere, and this glow is structured in bands that march with atmospheric tides and gravity waves, an ever-present signal that the sky is alive with quiet motion. Cosmic rays, high-energy particles from the galaxy, meet Earth's magnetic field and atmosphere with a steadiness that only slowly changes. The field guides and excludes some particles depending on latitude, so the count rises toward the poles, and when the sun is more active, the strengthened winds and fields reduce the number that reach Earth, leading to a gentle anti-correlation between sunspot numbers and cosmic ray intensity measured by detectors on the ground. On timescales longer than a single cycle, cosmic rays help form radiocarbon in the upper air when they strike nitrogen, and that radiocarbon later enters tree rings, making a record of solar modulation and rare events that can be read century by century without rush. Sudden decreases in cosmic rays, called Forbush decreases, follow the arrival of strong solar eruptions that sweep some of the galactic particles aside, and these dips recover over days, leaving curves that match the passage of the solar disturbance through the heliosphere, a reminder that Earth is nested within a larger flow. The atmosphere itself keeps time under the pull of the sun and the moon. Thermal tides arise because the sun warms the day side and leaves the night side cooler. These heating differences drive global waves with periods of a day-and-a-half day that rise into the ionosphere and modulate its density and winds. Lunar tides weaker but steady lift and lower the air with a period close to 12.5 hours, and by careful averaging they become clear in long records. The combined effect is a layered orchestra that repeats without hurry, each mode carrying energy upward where thin air allows large amplitudes. Satellites feel the upper air as a drag that changes with the sun's activity, because heating and ionization can puff the thermosphere outward by hundreds of kilometers during active times, raising the density where low satellites orbit and increasing their deceleration. This change helps clean the sky of small debris by hastening re-entry, and it eases again as the sun calms a breath that spacefaring engineers include in their calculations, and that ground trackers confirm in orbital fits. On the ground, long conductors can feel geomagnetically induced currents during strong events, when fields change more rapidly. Operators monitor these currents and adjust loads, and the larger story remains one of resilience and anticipation, built from many years of statistics. The Schumann resonances, natural electromagnetic tones of the cavity, formed by Earth's surface, and the ionosphere ring most strongly near 8 Hz, and at higher harmonics driven by lightning strokes around the globe and their slow drifts across seasons and cycles, reveal minute changes in the height and conductivity of the upper boundary, another quiet tie between space and ground. He lets measurements of the neutral atmosphere meet those of the charged environment. Satellites of the National Aeronautics and Space Administration and the European Space Agency fly through the thermosphere and exosphere and count atoms, measure temperatures and track winds with instruments that look at the limb of the Earth and at the stars through thin air, while ground networks watching the total electron content through signals from navigation satellites map the ionosphere's daily and seasonal patterns. Together, these views show travelling ionospheric disturbances that move like ripples from sources such as mountain waves, auroral heating, or sudden changes in the wind, and the ripples travel equatorward and poleward with speeds and wavelengths that match models of coupled layers. None of this requires alarm to be meaningful. The aurora's expansion follows the arrival of a southward magnetic field in the wind. The ionosphere lifts and falls with sunlight and tides. Meteors bring a steady dusting. Noctilucent clouds brighten and dim with season and temperature. cosmic rays modulate with the solar cycle and upon rare, strong events, and the thermosphere breathes in step with activity. The planet listens and responds gently, and in that exchange daily life continues largely untouched, even as instruments turn the responses into knowledge. He closes this section with the image of a night in high latitude, where a green arc bends over a calm sea, while higher in the sky the red air glow forms faint bands, and now and then a meteor traces a short silent line that fades to a point. Far above the ionosphere keeps its layered conductance. Farther still, the magnetosphere holds its shape against the wind, and beyond that the heliosphere faces the galaxy. Earth sits within these nested shells, not isolated and not overwhelmed, but serenely engaged, and the signals that reach the ground are small invitations to remember that the planet belongs to a wider gentle rhythm. He turns inward to the hidden furnace and the field it sustains, and he imagines Earth as a layered sphere whose quiet heart moves beneath rock and ocean, with a steadiness that keeps the planet softly shielded within the sun's wide breath. Seismic waves from earthquakes reveal the arrangement without opening the depth, showing a solid inner core of iron alloy, wrapped by a liquid outer core, both surrounded by a thick mantle of slowly convecting rock and a thin crust that bears continents and seas. The inner core is small compared with the whole, yet central. In function, a compact sphere where pressure holds iron in a rigid state, despite high temperature, while the outer core flows like a heavy metal ocean that never rests. In that flowing shell motion of conducting fluid under rotation and buoyancy, builds an electromagnetic engine called the geodynamo, and this engine stretches, twists and folds magnetic field lines until a global field emerges that reaches far into space. The sources of motion are gentle but persistent. Heat leaks outward from the core into the mantle, and the outer core cools enough that the inner core grows by slow crystallization, releasing latent heat and light elements that rise as buoyant plumes in the liquid metal. Rotation organizes the flow into columns that align with the axis and into spirals that imitate weather in a deep metallic sky, and together these motions sustain a field that resembles a tilted dipole near the surface while carrying complex shapes deeper in. He considers the field as a veil that deflects charged particles in the solar wind and traps many within donut-shaped belts, guiding some toward the poles, where auroras glow, sparing the atmosphere, a stronger erosive wind, and letting living systems proceed within a mild flux. The veil is not fixed. It drifts and wobbles and changes slowly in strength, and ground stations that have kept long records show a secular variation that can be mapped like a slow tide. A weak zone over the South Atlantic reveals itself to satellites that register more energetic particle hits when they pass through a patch that expands and shifts with years as the field within the core rearranges itself. Reversals of polarity occur on timescales of many tens of thousands to millions of years. When the field weakens, becomes complex, and then strengthens again, with the opposite sign, and lava that cools at the surface preserves the direction in iron minerals that align like tiny compass needles, building a layered archive read by paleomagnetists who see bands on the ocean floor that mirror across mid-ocean ridges. He lets the evidence gather from many paths. Seismic waves travel faster along one direction through the inner core than along others, hinting at aligned crystals or subtle textures that have developed over long time. Small changes in the length of day measured with careful clocks reveal exchanges of angular momentum between core and mantle through magnetic and topographic coupling, and satellites map the present field with exquisite detail. A trio named Swarm from the European Space Agency flies in coordinated orbits and teases out the contributions from crust-mantle-core ionosphere and magnetosphere, allowing models of the deeper source to be updated regularly with a tone that favours refinement over surprise. Heat flow at the core mantle boundary guides the vigour of the dynamo by setting how strongly the outer core must rise and sink to carry energy outward. That boundary is not perfectly smooth. Seismic images show broad provinces where the mantle is slightly slower to transmit waves, possibly related to ancient oceanic plates that have sunk and pooled, and thin layers just above the boundary, where composition or partial melt may differ from surroundings. These features modulate heat extraction and so influence patterns of flow below. In the mantle above, convection moves heat upward through slow solid creep that over geologic time drives drift of plates at the surface. The plates carry magnetic minerals that lock in the field direction when they cool, and they record reversals and wanderings of the poles that can be compared among continents to reconstruct past geography. The field near the surface looks simple, yet deeper within, it becomes a tapestry of loops and patches that wander like weather systems, and numerical models that solve the fluid and electromagnetic equations under rotation, buoyancy, and reasonable material properties produce fields whose large-scale features resemble observations, including drifting flukes patches and occasional reversals while remaining calm on human timescales. He rests with the knowledge that the dynamo is self-regulated. If the field grows too strong, it suppresses some flows that generate it and thereby softens. If too weak, flow proceeds more freely and strengthens the field, and the outcome is a balance that holds for long periods. Heat sources are likewise steady radioactive decay in the mantle, contributes to the planet's long comfort, while the core's cooling and inner core growth provide energy to move the metal ocean. The exact age at which the inner core began to crystallize remains a topic of careful debate, with some studies favoring a few billion years ago, and others pointing to a younger onset, and the choice matters, because inner core growth adds a robust driving force to the dynamo. He keeps such uncertainties gentle and useful because they motivate measurements that will refine the timeline without breaking the story of continuous shielding. Electrical currents within the mantle and crust induced by time, varying fields from above and below reveal conductivity that in turn hints at temperature and composition, and magnetotelluric soundings that compare natural fluctuations of field and electric potential. Gather these hints into profiles that confirm a warm, partly hydrated mantle under continents and a more conductive path beneath old ocean basins, tying surface geology to deep structure. He lets the coupling between layers feel like a soft handshake. Topography at the core mantle boundary can steer, flow thermal winds can adjust to lateral variations in heat flux, and magnetic stresses can tug between core and mantle, all producing tiny drifts in rotation and in the field that are measured and then averaged into a serene picture. The field interacts gently with the atmosphere and oceans as well. Currents in salty water and in the ionosphere slightly modify signals at the surface, and separating these contributions teaches about tides and winds while clarifying the deep source. He imagines the inner core as a slow crystal garden growing inward, perhaps with an outer region, distinct from a more aligned inner seed, perhaps with hemispheric differences in texture, and each possibility leaves fingerprints that careful seismic studies begin to see in the speeds and reflections of waves that cross and return. He considers the long memory in rocks. Basalts at mid-ocean ridges freeze with stripes of alternating magnetization that show when the field has flipped, and baked clays in ancient hearths preserve a record of field intensity that archaeomagnetists read to reconstruct regional strength over millennia and these lines of evidence join to tell how the dipole waxes and wanes while the planet remains calmly protected. He closes with a quiet image that holds the tone. Deep below, an ocean of liquid metal circulates along helices drawn by rotation and buoyancy, and within that motion magnetic lines thread and fold, joining into a globe encircled by a soft dipole, whose axis wanders slightly with time. Above the mantle carries that pulse forward as slow convection, that moves continents by only centimeters per year, and the surface feels the result as a stable field that points compasses guides, animals that sense subtle gradients, and guards the upper air from a harsher rain of particles. The system breathes across centuries and across millions of years, strong enough to weather reversals and gentle enough to change without shock, and it sets the stage for the final step of the story, where open questions in a gentle night invite rest rather than urgency and leave room for wonder to remain. He arrives at the gentle edge of knowing where the facts have formed a calm floor, and the open questions drift overhead like slow clouds that never threaten, only invite longer looking, and he lets the night hold them without hurry. The universe expands with the steadiness that instruments have traced from the afterglow to the present day, and yet a deeper pressure appears to urge that expansion onward, a smooth component often called dark energy that behaves like a constant background push. He considers this not as a riddle that demands alarm, but as a soft gap in the map, a place where further light may someday show whether the push is truly constant or a little warmer and cooler across time. Galaxies move upon the scaffold of unseen matter that collects in halos and filaments, and the evidence for that unseen mass is broad and calm from the bends of light to the speeds of stars, yet the identity of the mass remains open. He lets the possibilities rest like stones in a garden, each with its own quiet shape awaiting the next precise weight from deep detectors under rock, from patient counts of star streams, or from the faint glow of rare interactions that skyward instruments might record. In the first billion years, stars and small galaxies assembled and released enough light to lift fog from hydrogen gas and make space transparent, a transition called reionization. He wonders how widely that light was shared, whether bright bursts or many more modest lanterns did the work, and how the small structures survived the glow that warmed their reservoirs. The new telescopes that gather infrared light from very distant cities of stars will add layers to the portrait, and their results will not end the tale but smooth its outlines. He turns the question of habitability with the same even hand. There are planets around many stars, and small worlds are common. Mild zones where liquid water could persist on a surface are common as well, and the atmospheres of some of these worlds will soon be read by instruments that separate their colours with care. He imagines a spectrum with a hint of gases that do not easily coexist without replenishment, and holds the thought gently, knowing that planetary chemistry can be inventive without life, and that a cautious, layered inference remains the most restful path. Beneath ice on ocean moons, chemistry proceeds in darkness with energy from rock and tide. He imagines gradients maintained across vast spans and slow cycles that move salts and organics from place to place, and he leaves the question of biology there as a soft invitation to follow the trails of grains and vapours that future craft will taste. The sun follows its cycle of about 11 years and breathes through the heliosphere while planets keep time. He wonders how the field of the sun changes over centuries, and whether long quiet variations modulate the gentle rain of cosmic rays in ways that the records of tree rings and ice can continue to refine. The Earth holds its own interior engine. The field wanders, weakens, strengthens, and sometimes reverses. He accepts that the next reversal will arrive on a timescale far beyond any individual lifespan, and that the shielding will not vanish, only reshape, and he regards the study of this change as a lesson in patience across generations of measurement. He keeps the small puzzles at galaxy scales near the front of the shelf because they glow with promise rather than urgency. The inner density of some dwarf galaxies looks gentler than simple laws of collapse would suggest, as if feedback from star birth and the small winds of dying stars had softened the core, or as if the unseen matter responds to itself with the lightest touch. He considers both, and allows both to sit until maps of motions and star streams refine their verdicts. Satellite galaxies around larger hosts sometimes gather into planes or thin swarms. He acknowledges that the patterns may be partly an effect of where faint members can be seen, and partly a memory of how small companions arrived along filaments, and he lets the statistics grow with surveys rather than chasing a single conclusion. He returns to the rings and asks how long the bright icy spans of Saturn have kept their clean face. He accepts that mass meteoroid fleeks and the slow grinding of grains in light impose bounds that continue to narrow, and the answer can remain open while the dart deepen. He listens for the soft stir of gravitational waves at the longest periods, the slow heave of space made by orbiting giants that circle one another for millions of years. Pulsar timing networks keep the beat and have begun to hear a background that may be the sum of many pairs of black holes, a distant murmur that will gain tone as the years of timing accumulate, and the accumulation itself is a comfort, because it shows that patient addition still builds new music. He thinks about the chemistry of early star birth, when the first heavy elements were rare and cooling relied on simple molecules and the dance of hydrogen. Did the first stars favour greater mass, and how did they spread their ashes across the young web? He knows that faint galaxies in the deep fields and the patterns of absorption against bright background sources will add detail, and he trusts the pace at which that detail arrives. He holds the question of whether physics beyond the current standard might reveal itself in small departures within the afterglow's fine structure, in the distribution of light elements left by the first minutes, or in tiny deviations within the paths of particles made on Earth. The world's accelerators and the sky's detectors together can test these possibilities step by measured step without pressing the sky for haste. He wonders too about the long future. The expansion will continue. Star formation will decline. Galaxies will keep merging while the overall glow dims. Planets will drift through older systems that still hold warmth within from slow decay. Black holes will collect and relax, and the background afterglow will stretch into wavelengths so long that any local receiver would find only a hush. None of this carries sorrow. It is a long relaxation, a cooling into wider and quieter forms in which motion remains but the tempo softens. He places one more question on the gentle table, whether there are patterns of intelligence beyond Earth that leave marks subtle enough to escape easy notice, yet robust enough to be found by persistent and calm watching. Beams that repeat waste heat that exceeds natural balance, minor excesses of gases in a planet's daytime sky that do not fit with simple geology. Such signs, if they exist, would require rules and patience to see, and so the search proceeds as a background hum, ready to accept both silence and whisper as informative. He closes this circle of questions by returning to the mood that has carried the story. The cosmos has shown itself to be readable by instruments that do not rush predictable in its cycles and generous in its patterns. Where uncertainty remains, it takes the shape of room, not crisis. The open edges are not cliffs. They are soft horizons that recede as one walks, leaving behind a longer, smoother path. He stands upon that path with the low note of the first light still sounding, with galaxies turning like distant clocks, with the sun breathing with planets in resonance, with oceans under ice, with rings that shiver and settle, with comets that return on time with auroras, that glow in response to quiet winds, and with a field from deep metal that shields the air. The questions rest upon this foundation, as stars rest upon halos, as waves rest upon seas, and they promise not answers that end the night, but further textures in the same calm fabric that invites the mind to soften and the world to dim.